don't know where she went. Oh, she's at the back. She's not specifically looking this way, so you want to give her a thumbs up for me? I do. Okay, this one. It has to be held too. Okay. And then I want to turn this one on. That one looks good.
Hello everyone. Thank you very much for coming to this month's Spilling the Beans. It is our largest to date because we have opened it up to more people than usual because the topic is really exciting for the Edmonton Valley Zoo. My name is Catherine Shire. I'm the conservation coordinator here at the Edmonton Valley Zoo. It's the first dedicated conservation position at the zoo, and it's really working to continue to enhance the Edmonton Valley Zoo's conservation efforts because zoos around the world are starting to understand their unique role in conservation. And the topic tonight is also one where the world of research and conservation connects here at the Edmonton Valley Zoo. And so we're really excited to introduce a partner and a part of our zoo family on some of the work the research work that's being done here at the zoo. So thank you to coming to Spill the Beans. It's called that because we also use this opportunity to educate about bird-friendly coffee, which hopefully many of you are testing out today. Most of the world's coffee is grown in the sun, and that is not a traditional way to do it. And when you grow coffee in the sun, you lost herbicides and pesticides, and you also have to take down a lot of the natural habitat down in South America, Latin America, which our migratory birds actually rely on when they head down there in the winter. So here at Edmonton Valley Zoo, we're committed to teaching people about what they can do by purchasing bird-friendly coffee, which is organic coffee, but it's also coffee that's intended to enhance habitat in our migratory birds' southern homeland. And so before I introduce our speaker for tonight, I would like to acknowledge the traditional land in which we reside in Treaty 6 territory. We'd like to thank the diverse Indigenous peoples whose ancestors' footsteps mark this territory for centuries, such as the Cree, Saulteaux, Nakota Sioux, Blackfoot, and Canadian peoples. And we also want to acknowledge that this is the Métis homeland and home of one of the largest communities of Inuit south of the 60th parallel. So together we want to call upon all of our collective energies to try to conserve the flora, fungi, and fauna of our land for future generations. And so today our great speaker is Dr. Jenna Congdon. She is an assistant professor at Congdon University here in Edmonton. Her graduate studies investigated perception and communication of predator threat in black-backed chickadees at the University of Alberta. And then she went to York University where she worked with Sumatran orangutans as part of the Toronto Zoo's animal welfare science team. In the fall 2022, we were lucky enough to have her come and visit us at the Edmonton Valley Zoo, and she has since established the CLAW Laboratory, which is the Cognition, Learning, and Animal Welfare Laboratory that works with Edmonton Valley Zoo to study cognitive abilities of many of the residents that we have here at the zoo. And she also has many students, the research of which you're also going to see today, whose research has had a variety of other animals in our care. Much of this research we're going to learn about today. So, welcome, Jenna. It's lovely to have you.
All right. I'm reasonably loud. How are we doing? Doing okay. Awesome. Okay. Thank you for being here. I'm really excited to give this talk. So as mentioned, modern zoos are committed to 3 pillars: conservation, education, and research. So I'm happy to be presenting on the commitment to research here at the Edmonton Valley Zoo. It's going to be a pretty busy talk. There's a lot we've been up to in the past couple years. So I'll give you a bit of an overview. So to start off, I'll talk a little bit about how I came to be here to collaborate with the Edmonton Valley Zoo. Forgot there was an intro, so I can probably speed through a little bit of that. And then I'll spend the rest of the talk really focused on the incredible work of my students, both previous and ongoing, so you're getting a bit of a hot off the presses experience here. And some of the touchscreen research that you've potentially heard about if you've been around the zoo lately. So, my own research history, my master's and PhD were studying songbird communication and perception of predators at the U of A in the Songbird Neuroethology Laboratory under the supervision of Dr. Chris Sturdy. Black-capped chickadees have incredibly complex vocalizations, actually comparable to human language. So they're a really great model species to study, and I did so in the lab in the field. Towards the end of my degrees, I spent time flying down to Arizona, actually, to study desert ant navigation with Dr. Marcia Spetch. No one was studying this species at the time. It's a species called Veramesser purgandii, and I could do an entire other presentation just on how intricate their navigation is. Big fan of these little gals that you may or may not be able to see on my finger there. And then my postdoctoral research, as mentioned, was with York University and Toronto Zoo, so I was on their science and welfare team at the time. Specifically, I was training artificial intelligence to be able to monitor the welfare of Sumatran orangutans. Much of my heart will always belong to this great ape species. They're pretty impressive to work with. So across those three experiences, I've worked in a lab, in the field, and also with a zoo. On a personal note, I wanted my career to be at a small teaching-focused, student-focused institution, which is why I wanted to work with Concordia, University of Edmonton. So I moved back here to be a professor at that institution 3 years ago, as mentioned. And then in developing my laboratory, I reached out to the Edmonton Valley Zoo. They were extremely encouraging and supportive of a research collaboration, and that's what we get to talk about today. But before we get into the projects that I want to discuss, I just want to go over a few things so we're all on the same playing field. So first of all, I'm actually in psychology. Sorry about the smaller screen font there, but I'm actually in psychology. Most people immediately assume it's biology or zoology. Psychology, when you really break it down, it's the scientific study of brain and behavior. I think everyone in this room can agree that animals have brains and they have behavior. So I'm in a specific area of psychology called comparative cognition. So the idea there is that we're looking at the mental processes across species, both human and non-human animals. So the reason I like working with zoos is because they care for exotic species that don't belong in laboratories, and those same species are quite difficult to study their cognitive abilities when you're looking at them in the wild. It also creates great opportunities to understand our animals better, create cognitive enrichment opportunities for them as well. And this entire wonderful section over here, as well as another row over there, are the zookeepers. And they're incredibly highly skilled trainers that have been really excellent to work with. So as mentioned, the title, Cognition, Learning, Animal Welfare, is what makes up this claw lab. I didn't make up the title, don't give me the credit. I needed help for that. But that really breaks down the two sections of my lab. Most of my student projects are focused on animal welfare, and that's through providing enrichment. The thing that gets me out of bed is the cognition part. I really want to know that kind of question of what are animals thinking. So that's the cognition and learning component. So when we're talking about enrichment, provided definition there, that it's really about enhancing species-specific behaviors, making sure that those are occurring in these environments. So there are many types of enrichment. You may see slightly different terminologies for this, but generally, as presented, the occupational enrichment is talking about activity and motor skills. Cognitive enrichment is that mental stimulation. Social is providing opportunities for animals to interact with other individuals. Physical is often providing structures for more natural behaviors. Feeding, foraging, I think you probably have that one. And sensory comes down to the 5 senses. So this can be providing music or scents or different materials for the animals to engage with, touch, etc. So I'm going to be going through my previous and ongoing student projects to start off. This is Brooke. Brooke was my very first student of the lab. The projects tend to be driven by my students' interests. Of course, that's in collaboration with the zoo, so we have to determine the feasibility, we have to determine the interest in participating in that particular research project, but most of the time we find a nice way to make the students really happy and excited about the exact experience they're looking for. So what Brooke wanted to do was work with our sweet white-handed gibbon, Sulaway, and she wanted to create some enrichment for him that maybe didn't already exist. So we met with the keepers, we asked them about their needs, and we wanted to create a reusable sensory enrichment so they can use it multiple times rather than, maybe being ripped apart and try to be reused elsewhere. And we wanted to do it without food enrichment so that he's just engaging with it for the sake of engaging with it. Through her literature review, she found out that gibbons actually like purple and yellow-orange colors quite a bit, which you might notice he's engaging with the yellow rope there preferentially. This video. His fingers are right here. If you can see, he'll move around. He really liked the purple. He really liked the yellow. He went from spending about 3% of his time doing what we call object manipulation to 30% of his time during our observations, engaging primarily with this, some other things that were put in the space. So that was pretty exciting for Brooke to actually see him engaging with it. So there's no food hidden anywhere. I also have some videos of him playing with the lock, which was a fun component to see. So that was a really great day at Home Depot. We spent a lot of time building that. Laura helped us gibbon-proof it, which is mostly trying to destroy it. So we had to rebuild it. It was not gibbon-proof yet. It is now. So that was an exciting first project. The next up is Daniela. Daniela's right there. And Daniela is actually now a zookeeper. They stole her from me. But Daniela actually was in class with Brooke, funny enough, and wrote a really incredible paper on Amur tigers, looking at enclosures across many different zoos, as well as enrichment ideas. And I basically begged her to be in the lab, which ended up being a really fun part of last summer, in which her idea was to build, really normal idea, which was a 6-foot-tall fire hose deer. So this is recycled, donated fire hose that we have available. They built this cube for the seals, and then this really large feet for Amba. And so here we have Amba engaging with it. Another feature of it beyond the fire hose is that it has naturally shed antlers attached to it, as well as naturally shed camel fur. It was International Tiger Day. We really wanted to get her to interact with it for some photos, and she did. So she's just behind it right now if you can't see her yet. Little paw coming around. By the way, that took 3 of us to move, so she made quick work of that, and I mean quick work of that. She ripped off 3 of the limbs in the first night, so then Daniela had to get back to work with Taylor, of course, and they rebuilt it, and it still stands to this day. So we learned some things. And it's doing its job really well. We have engagement here, and this is without any food, any scents, and we got some occupational enrichment out of that. So very exciting. Taylor, who you might have also seen in those past little photos there of the fire hose deer, Taylor at that time was interested in working with red pandas. Specifically, red pandas are part of the species survival plan. So that's a commitment to a healthy, genetically diverse population. So that's something that's really incredible going on here at our zoo. And she wanted to create enrichment, specifically music, see if they were interested and in fact enriched by that. Previously, music enrichment has been seen to increase activity levels in dolphins, chimpanzees, piglets. So Congdon, our least active, we were trying to engage with some music enrichment. That means classical music. We had some natural frog sounds. We were trying a couple different options. He did come to check out the speaker, so that was exciting. We ultimately found out red pandas don't care. So they are not enriched by it, but it's also not aversive. And music not being aversive is very important as well, right? Events going on at the zoo, it's great to know they don't really care either way. This is a much better option than Sumatran orangutans. When given the option to pick between music genres or turn it off, they turn it off. Orangutans hate music is the summary of that study. Next up is Kelly, and Kelly had interest beyond mammals, so actually got to work with the raptor team, which was a very exciting opportunity. She is currently my only not Concordia student, so I co-supervise her with my previous grad supervisor and his graduate student, Mo. So Kelly has been spending a lot of time throughout the fall, winter, and then spring semesters. She was working with these 3 owls. So in the upper right corner, we have Cortez. He's a nocturnal spectacled owl. On the perch is Summer, and he's a barn owl. They can be crepuscular or nocturnal. Crepuscular means that they're active at dusk and dawn. And then Chutter right down here. She's a burrowing owl. They can also be crepuscular or what's called cathemeral, which basically means that their activity patterns aren't as consistent. More irregular intervals, if you will. So from spending time observing day and night, by the way, Kelly really committed to this project. Many hours of the night she watched these owls. Turns out Chutter's having a party every night, so that's great news. She's very, very active. And then we were coming up with some ideas for Cortez and Summer. So I'll start with Summer over here. Summer, basically, we wanted to increase activity. We were trying to do that by providing more perching options. So created this big stand. The stand has many different hooks and adjustments to it so that it can attach to the rest of the environment and also be modified as the keepers see fit. It's also less large than the giant fire hose deer, so it fits well in the spaces and can be used well by the keepers, hopefully ongoing. And then Cortez, this graph is his, which small font, but basically it's saying he's spending a decent amount of time doing preening, some self-directed behavior. We wanted to take that attention and shift it positively towards giving some other options to manipulate with his beak. So that's this fun box that you see here and here a little bit larger. So it's got all sorts of components to it that can be pulled on. So it's got some turf, grass, all sorts of ropes. So we actually haven't been able to implement that quite yet because we want to make sure we have a solid observation period, and the summer means the owl's moving outside. So hopefully we get to introduce that soon and it's received positively. After this talk, actually, we'll probably head up to Cortez with Michaela, and so we can actually get to see him and see a bit of training with Michaela, assuming he wants to. Choice and control are important. Next up is an ongoing project with Adara, who's been funded by NSERC all summer. And this is a very wide-spanning project. So it's basically taken the whole team, the existing team and the volunteers we've had this summer. So this is an investigation of the impact of enclosure designs on welfare. And we have picked a very casual 4 species. So serval cats, snow leopards, Canada lynx, and Sichuan takin. The first 3, these carnivores, we're spending time seeing where they spend their time, how they spend their time, and we also have a decibel meter to take a look at sound levels in the area, as well as we're looking at how many people are in the area and trying to see if there's any kind of behavioral patterns according to that. This is really useful for the zoo to have this information about their animals. It can also be really useful when you're planning new habitats, new enclosures, to be able to have a bit of that baseline information. So I'm not going to talk about the serval cat today, just in the interest of time. So I'm going to jump right to the snow leopard after I explain what this photo is. So there's currently an app out that many zoos have started using, which is called Zoo Monitor. I learned about it at the AZA conference that was in the fall. And so my students took some time actually meeting with the designer of this application to be able to understand how we could use it here. So Adara spent an incredible amount of time building maps of the enclosure spaces so that we can use this and input this individual's in this space doing this activity, and then here is the point on the map that it's spending its time. So that's what we're going to take a look at. So these are called heat maps. Essentially what it is where their behavior, where they are spending their time, there's going to be a point on the map. And the blue means they spend some time there, and then it's going to go through green and yellow and red. Red is where they spend most of their time. So you can start to have an idea of what that looks like. So to orient you, if you've been to the snow leopard recently, this is where the wolves used to be. This is where the foxes are. And to this side would be Lucy. So standing at this corner is a great spot to see the enclosure. And if we're looking at the heat map, you can tell that she is a big fan of this rock right here. She spends a lot of time under that. And then also the shelter over here. So she spends time inside of that, sometimes on top of it as well. We're currently processing the data of the serval and the snow leopards in terms of how they actually spend their time. I will tell you though that Indira, 12 years old here, she loves laying on her stomach, and she loves laying on her side, and she loves laying on her back, are so far most of the pie chart. We do have a behavior in our ethogram called big stretch, and it's for this gal right here. Next up are the lynx, and we actually have 2 lynx, mother-daughter, Xena, Artemis. And with the lynx, you're going to be able to see 2 maps back to back with mom and then daughter. So this is Xena first. She spends a lot of time at the rock here and this kind of sheltery area, platform, I guess. This is where the wolves would be. This is where the foxes would be. And then the other side is where it meets up with the serval cat. She spends a bunch of time on top of the shelter and underneath the shelter, as well as this is trying to show you a rock, not the platform. But yeah, the activity patterns change quite a bit between these 2, so take a look at it. And this is Artemis. So she's a little bit younger, so that could probably be a decent part of it. We've got 13 years old versus 4, so she's much more active. If you notice though, she's not using either of these spaces at all, which is a pretty cool comparison. She does lay on top of the shelter. She does like underneath the rock as well. She also likes to spend some time at the wall with Blade, the serval cat, having some interactions there and moving around the space. A lot of these photos, by the way, are Kelly's photos, and they're pretty incredible. So I'm going to move into the talk-in now, which we've really been enjoying this particular project, in which we mapped out the existing shade. The keepers already wanted to implement more shade. We wanted to provide the data that could then facilitate implementation of that shade. So we have 8 Sichuan takin, And we have 2 males and 6 females. They do have a hierarchy. They have a tendency to want to stay together as a herd. So when you're thinking about shade options, having shade that's enough for the entire herd is really helpful because they want to be nearby. I managed to catch this photo where there are 5 of them under the big existing hut in the left pasture. If you notice, there are 2 right up here, and then the third one, Fiona, is always somewhere much further away. But for the most part, they're pretty close together in the places that are offering shade. So we handed over that information of where the shade currently exists, where they spend some of their time, what our recommendations are of where to put some shade. And so they got to work pretty fast with this, very small. We have Heather and Kaylee here after successfully putting up this sail. So these shade sails, the more we spent time with it, they aren't as optimal as some of the other things we came up with, but they have come around to the shade sails, so this is exciting. They are a prey species, so having something over top isn't going to be as comfortable as a wall, but it's a good option that was easy to implement quickly and efficiently. What we also managed to get put in was a shelter in the right pasture. This has been pretty thrilling. It was mostly thrilling for me to watch these 2 get the shelter in that space. Katie and Jenna are incredible operating those machineries. And the cool thing is they're using it immediately. So on the right, we have a few photos. I'm just getting used to taking photos through binoculars, so don't judge me, mostly Nick. And they are using those spaces, the shelter, the back, the inside. And over here, these are just temporary for now because we want to see if they actually are going to use them. So some nice temporary, essentially walls to cast some shade. But if you are capable of seeing here, they are immediately finding any pocket of shade and they're using it, which is awesome. Very exciting for the students to see in real time that we made a change and it's working. So this is pre-shelter. We did do some observations before we got Zoom Monitor running. So there's a little bit of data missing, but we think it paints a pretty good picture of how they're spending their time. They move around. They typically move around together. They use that big hut that was in the photo at the beginning sometimes. And then basically any shelter that exists, they are finding sides of it as the sun rotates throughout the day. They're finding those pockets of shade. Now, they're spending a lot of time in the right pasture. This is where they feed them. No surprise, they like food. So they're over here, but there was no existing shelter at that point for shade, so that's why the shelter was brought into the right pasture, which, again, very exciting. So we'll take a look at this. This is pre-shelter, before those walls were put up. The walls are put up right about here, by the way. And this is post. So they liked the shelter, which is really exciting. They also quite like the walls. And actually, when my students met with the guy who made Zoom Monitor, he had actually also studied Sichuan-Takin, and he found the same thing, that they prefer walls instead of overhead, but this is where the sail was put up. So they are using it, preferentially spending more time in that space. So it's really exciting to see. By the way, this is also where their water is, right there. So you're going to see a lot of attention to that section as well. Okay, the final student project is Taylor again. I've had Taylor for a while. It's been absolutely excellent having her, and she designed some pretty cool experiments. What she was excited about for fall, winter, and then paid this summer with another NSERC was the idea of social cooperation rope pulling. So what this means, this is a particular methodology that was actually designed in 1937, although the published research is much more recent. The idea is, can 2 individuals work to problem solve? Can they work in this social cooperative way to be able to pull food that is previously out of access into access? So that's what these wolves are doing right here. Food is essentially behind a fence that I've blurred out, and they would be pulling it into access together. Wolves are excellent at this. They're pack animals. It makes a lot of sense. This has also been done with dingoes, domestic dogs, Asian elephants, and bottlenose dolphins. Wolves are good at this. Dogs are terrible at this. So they can learn how to pull. They do not want to pull with a friend. And that's because we're their friends. So they don't work as well with other dogs. It has been successful in many species. The videos for the Asian elephants pulling are pretty darn cool. So we proposed working with the red-necked wallabies right here. And we got our very own dedicated trainer, Steph, here. So size idea of how big a red-necked wallaby is. Comparison to human. And what we wanted to do was, first of all, see if they can even do this at all. It turns out nobody is studying any species of marsupial in these kind of cognitive questions. So it's really novel stuff to be doing. We had no idea what an apparatus for a wallaby would look like, and we had to figure that out. It's harder to make than you would think. It seems so simple, but we had fun. So what I'm going to show you is the very beginning of this. Steph's working hard here with an entire pile of wallabies. And what she's doing is the apparatus is here, and there's a rope, and we're just trying to get them used to the apparatus. So we want them to be comfortable in this space. We want them to be engaging with the apparatus. So Steph's watching each of these individuals simultaneously, and she's feeding them as they're having interactions with the rope. So first, we start off with proximity, a 2-foot proximity. They're going to get fed every time they're in that space. Then they're going to get fed every time they have a successful interaction. And that's what that can look like right there. It could just be picking it up. Then we move to having tension in the rope, and then we move to actually pulling the rope forward. So these successive approximations to the goal that we're trying to get behavior-wise. So this is ultimately what we came up with for the apparatus. This is in the training stage, so it's just one individual pulling once we get to that point, and they would pull the apparatus forward. It would reach up with the fence line, and that bit would come through. They'd have access to the food. So this is just a drawer mechanism. I'm apparently not a carpenter, and that was really hard to make for me. But we figured it out. Taylor's been dealing with it very well. Essentially what these graphs are showing is that they are learning it. These are very preliminary data back from winter, but we had 5 of them that were all working at it quite well. So what does that look like? This is the fun part. So on the left, that video will be running. And this is earlier parts of training. They will even do this in the rain, so that was also really exciting. That weather wasn't a barrier. And so you'll see it's a little bit slower there. Let's see it as more recent training. We got to a point where Taylor couldn't keep up necessarily with getting the food in there. Thankfully, there were no lost fingers. So training went really well. In fact, it went really well like this. So what this is showing is that Grace and Arvo are immediate rock stars that went well through training. And so they were hitting their maximum diet allowance after 13, 14 sessions. So that was really exciting to see. We had a couple sleepers that finally figured it out just in time. We're on a tight budget of time with the summer, and they did figure it out in time that Toki and Polly, especially Polly, figured it out. We were actually doing really well with Axel for a while. It's not that he did well and then dropped off. It's just that when we moved to doing the outdoor and the fence line, he didn't seem to like it so much, and we had to make a decision to move on. Unfortunately, without him. But with the 4 of them, we have some nice pairing options to start testing the social cooperation aspect. So to give you a run through of the new apparatus, so shiny and different, it just has 2 pieces instead of 1 because we need to feed 2 wallabies. And what's happening now is instead of the rope being attached to the front, it's fished through the back. So it is 1 rope. So if one pulls the rope and the other is not pulling the rope, it does not come forward, and it's unsuccessful. They have to pull the rope together at the same time for it to work. So this is actually day 1, I believe, Grace Arvo, and we have some interest in the rope. It's very suspenseful watching these things in real time. They're almost at the same time. They're a little frustrated by the fact that it was once easy success of 20 treats in about 3 minutes, and now it's taking a bit more work. This one was yesterday. Same individuals. Pretty quick work of that. So it's really exciting. We've gone from 1 in 10 trials of success for some of the individuals to half of the trials being successful. And it's not that they're not interacting with it, it's just that one might be a little bit faster. Pretty exciting morning today where one was pulling the rope was almost gone, and then the other jumped over just in time to grab it last minute. It's exciting stuff, I swear. So if you want to hear more about this, my students do it even better justice than myself. Taylor and Adara in about a week and a half. They're going to be presenting at Concordia at what we call Summer Research Day. So they're fully funded summer students. I don't have a QR code for that yet, but feel free to email me. I'd love to have more people come to their talks because it's going to be really fun. We've previously had many of the zookeepers come to student talks, and it's been excellent. Okay, so now what I'm going to switch to for the final part of the presentation is talking about this touchscreen research you may or may not have heard of. So when I started working with the Edmonton Valley Zoo, I reached out to some of my colleagues, specifically Suzanne Gray. She has some incredible ideas, and one of the great things about international collaborations means that we can share ideas and resources. So she was very interested in some visual perceptual questions, what we call the global local bias problem. And in this case, she was working with Franklin Park Zoo and Zoo New England, and she had a whole variety of bird species that she wanted to ask this particular question, which I will get into in a second. But she was working with some emu. We had some emu at the time, so we decided let's share some resources of having a larger sample size. So this meant building a giant touchscreen for emu, which was really fun. And the idea of the global local bias is how do we process information? There is essentially this infinite amount of visual information at any one time. How do we prioritize what's important to us? So historically, humans are global, meaning that we essentially take in all the information. We take in the big picture. When they started looking at this problem across other primate species, they found that it was more mixed. So our closest primate relatives are actually global or local, not just global, depending on the species. So that's interesting. It brings up some evolutionary and ecological ideas of how this would come to be in the way that we process information. So we want to know more about that and essentially map it all out. And that's why she was starting with all these species of birds. Also, the way this has previously been done hasn't always been consistent in the methodology. It has been consistent in using what's called hierarchical letter stimuli. Fun, exciting stuff for your Thursday evening. What this is essentially global configurations and local configurations. So global is the top. This is the thing that humans are going to respond to quickly because you probably see a large N and a large P. It's actually just a series of small O's in that configuration of an N and a P. And the local configuration is essentially the opposite, that we've got a large O made of small N's and small P's. So the finer details. So when you start to look at other species, including many species of primate, Pigeons, chickens, they're also very local on this particular task. Global, however, are split fin fish and honeybees. So when you think of the way that fish and honeybees navigate the world, it's on this very global scale, right? Whereas when you probably think about the way chickens and pigeons eat, it's pretty local. It's focused on those fine details, right? So that's the way you can kind of think about this. This is actually the first level of testing that would be shown on the touchscreens. We will see a little bit of that as we go. So this started off with emu and two incredible zookeepers, Joelle and Trevor, that volunteered to do this with the emus, figuring out how to get our emus to work with a giant screen on stilts. Trevor had a genius idea of taking grapes, cutting them in half, and just sticking them to screens. That was the moment, so that was exciting that they finally started interacting. And you do enough of that and they start to figure out what they're supposed to be doing with the screen. Here's a video of Joelle with our previous rock star buddy, female. And what she's doing right now is responding to anything with a P. She was excellent at it. Buddy on the right, female, and Amos on the left, male. They unfortunately have since both passed away, but they were excellent first subjects. So Buddy was good at it. She seemed to lean more local. We didn't get to finish that particular level of the experiment, but it was in line with Suzanne's emus as well. Before we lost our emus, though, they were very old emus. I got some money to be able to expand into other species, starting first with the herber seals and the fur seals. So the apparatus immediately needs to look a little bit different. Unlike the emu apparatus, which was trying to be in line with what Suzanne's looked like, no one is doing any touchscreen work with seals. There's a little bit of button pressing, joystick using with California sea lions, but no touchscreen in the way that you enter your face towards it. We basically wanted to make seals peck the screen to be most comparable in methodology. If you might be able to see, they're wet animals. They're very wet. So this means changing the screen as well. So if you've got kind of this touch screen, works like a normal touch screen. If there were going to be water residue on it or fish scales, as these folks know very well, it would affect the responding on the screen. So what happened was we reached out to someone who makes incredible touchscreens, and I told him our idea, and he built me essentially what's called a glassless waterproof touchscreen. So this touchscreen here, it's a normal computer monitor, and then it's got a screen on top of it that looks like a frame, and it shoots infrared beams. So there's no screen to leave any sort of residue on. So the idea is that they have to enter and break those infrared beams to respond to the right part of the screen. Although they are very wet, so we did they taught them how to dry their faces. So that's been very helpful for the longevity of my equipment. So again, this is the kind of difference between the experimental apparatuses. Trevor is here with the emu, and this is what the back of the touchscreen looks like. The reason I'm showing you the back is we don't want to have what's called an experimenter bias. We don't want whoever is feeding that seal to accidentally lean one direction or the other of what the right answer is. The seals are very attentive to their keepers and could accidentally be picking up on cues. So what we have at the back here is a light board. And the light board indicates if there's something on the screen and we're waiting for a response, if they've made a correct response and they need to be fed, or if we're waiting for the screen to switch over. So these lights, you'll notice in the videos that are coming up, that the keepers are standing behind them as they get higher in the experiment when we're actually doing the testing and collecting the real data so that they're not biasing these animals in any way. This light board was custom built by Ali, who is Suzanne's partner that was on the other screen there. So they're incredible collaborators of what we've been able to do together. So as a bit of an intro, we have harbor seals, 3 of them. That's hula, sushi, and wasabi. Great names. And we have our northern fur seals, and that's Isadora, Sophia, Misha, and Nika. The harbor seals, left and right here are the fur seals. You'll notice some drastic morphological differences in the way that they look. We've actually since removed the ball for the fur seals. They don't need it. They can lift their bellies up pretty easily and be at a good height, whereas the harbor seals, they absolutely need the help to get up to the screen height. So here is a northern fur seal getting her face dried by Karen to make sure that those screens last. And we had to take a look at what this procedure looked like. We tried to kind of start right away like we did with the emu. Training wasn't particularly an option, but it's a very different situation when you're working with seals. Trainers are spending time with them 3 times a day doing feeding, training, enrichment, also making sure that they have behaviors that are very useful for vet checkups, etc. So we had the opportunity to pull it back and try a different way of those successive approximations to the goal that we wanted of using the screen. So that's why you see a little white sticker here, if you can. So they typically use target sticks, that's what the pole is. And what they did was they put a white square on the end that kind of mimics what shows up on my screens, the very first stage. So that was kind of the starting point. That white sticker was then moved to a black board, then it was stuck to the monitor itself, trying to get them to poke it, and then the screen was turned on and we actually showed the things to get through all the different levels. So I'll show you the very first level. This is Heather with hula. She's currently at the side, which is really helpful when we're starting training them. If you start to move behind too quickly, they're kind of like, where did you go? Are you paying attention? Will you feed me fish? So sitting at the side is really helpful until they get a little bit more independent, if you will. One of the things you'll also see Heather doing during this time is she gives a physical cue. They have physical cues for many different behaviors, especially if you go to the 11:30 talks, really great to see. With the screen though, they came up with their own one, which looks like this, of interact with this monitor in some way. Heather, hopefully this isn't too loud. Okay. We need some encouragement at the beginning, so it's really helpful. So she's trying to figure out what she's supposed to be doing, right? She's been reinforced for touching this white sticker before, now it's illuminated, and so she's trying to figure out exactly how to do that. The good thing is, Heather spent a lot of time specifically teaching hula how to take her face back out. She was doing a lot of putting her face in and rubbing it all over the screen. Very cute, not super effective with the way that this equipment's set up, so she needed to pull back out as well. So that's where you see that. Next, you're going to see northern fur seal. This is Isadora. She's on the first level beyond touch white. So this touch white, the idea here is that they're tracking to the visual stimulus. We literally don't know if seals can see things on screens until they pass this stage. So they need to pass that stage with extremely high accuracy that they're attending to wherever this white square moves. Then we're giving them a decision. We want to make sure that when there's 2 images on the screen, can they choose? And so in this case, this is touch plus. Isadora is supposed to be responding wherever the plus goes. This is counterbalanced. It's not always going to be on one side. It's going to move around. And during this stage, again, we're making sure that she's properly touching the screen, not even really touching the screen, breaking the infrared beams in front of the monitor, and that she's doing so with high accuracy so that we know she has the ability to visually discriminate between these things before we start asking the actual data-related questions. So this is another touch plus. I wanted to show both. This one's with Talia here. Because Sophia just touches the screen a little bit different. They all have their individual personalities, so she kind of scoops up. She also loves to exhale aggressively. It's thankfully calmed down. I like, not this trial, but the next one. You can kind of see her intentionality, which is when it gets really exciting for us as experimenters. So right here, she looks and makes a decision to switch elsewhere. And so we're looking at that very first choice. We give them the opportunity, if they make a mistake, to continue on, but we're looking at the accuracy over time from those first decisions on each set of stimuli. And last here is the actual testing. So there are actually 6 phases of testing. We've gotten to this testing with one of our first eels. The second one's ready to go. We're just waiting for her to get through molting. This is pretty early on, so she does make one error, and then she learns from that and makes a different decision. So you can hear the sound going off, as well as the light board would be flashing the green. She's being reinforced for N. Buddy, the emu, was being reinforced for P. This is again randomized as to what they're getting. That was incorrect. That was correct. So she made a quick switch over. So I am actually going to show her data hot off the presses, especially for the zookeepers here, where this is very preliminary. Her accuracy isn't super consistent. We're kind of sitting in a 50-60% range, whereas they're expected to have high 80s to be able to move on. But what we see from the preliminary data is global is the blue line, local is the red line, and aside from right about here, she's consistently more global oriented. So that means she's responding with more accuracy and quicker to those global stimuli than the local stimuli. This was the opposite for Buddy the emu. And this is very much within our predictions, what we thought, again, the way they navigate underwater. So this is pretty exciting. I know at least I'm excited. Hopefully you can borrow some of my excitement. It's really nice to be finally getting to the point where we're getting this preliminary data. It takes a lot of front end to design the apparatus, to train them properly. There's always lots of other things going on, like molting. It makes seals honestly quite dramatic, so not always the best subjects to interact with, but there's a lot of encouragement of what this is looking like. We went to a conference in New Mexico recently, and the amount of excitement around this and being able to show off Concordia, University of Edmonton, as well as the Edmonton Valley Zoo and all the really exciting stuff that we're doing research-wise, being able to ask these kinds of perceptual questions. So in conclusion, the purpose of this research, my lab, is to understand more about non-human animal cognition, as well as provide enrichment for the animals here, which ultimately better informs welfare and conservation. It always helps to know more about the individuals specifically at our zoo and how that can potentially help their wild counterparts. None of this is possible without the financial support from my institution, as well as NSERC. They've been really incredible to us. Taylor dominates this. If anybody needs to hire Taylor, she's excellent. And we also, Adara has been doing some incredible stuff, fully funded projects, so this is awesome. So none of this is possible without the financial support to build these things and pay the students. My lab students and volunteers, they come up with a lot of these really incredible ideas. The international collaborators involved, and of course the critical partnership with the Edmonton Valley Zoo and their outstanding zookeepers. So it has been an incredible partnership, and I look forward to all of your questions. Yeah.
This is perhaps not related to your research, but I'm very curious why there's a tapping named Lord Farquaad.
Yeah, good. I'm glad you caught that one. Lord Farquaad, did you also catch that Fiona? Right? Yeah, they're both 4. I don't know, is there a decent reason that it was Lord Farquaad, or is this a public naming?
No, I named it.
You named him, Joel, yes. Joelle has naming rights. Well done. The number of times the public has appreciated when I'm like, oh, the blonde one, he's the top of the hierarchy. That's Lord Farquaad. And everybody is always excited and often gets the reference. Yep.
Did you notice anything different with the seal or seal line's behavior since you've been doing the touch screen? Like, is there any enrichment benefit that you've noticed outside of the trials?
Zookeepers, do you want to answer that one? The question was, have we seen changes in the overall seal behavior now that they've been engaging with the touchscreen? Heather?
From a keeper perspective, we do about 21 sessions with each individual week. That's 3 sessions a day with each individual, 7 days a week. In that session, we can choose to feed it by enrichment, do a research session if Jenna's available, or do a free feed, or of course do training where we work with husbandry. So it's just one of the things that we can include in our week. And out of those 21, only maybe 2 are research. So they are a small but important part of what we're doing, and they're a tool in our toolkit. We did notice an increase in pushing different things, which has been really fun for enrichment. Not so fun for some of our wellness behaviors, but they're very, very great and helpful for that. So just anecdotally, I would say that's pretty fun. Anyone have anything else to add?
I'll summarize quickly for folks in the back just in case. They do 21 sessions of training or enrichment throughout the week. I'm about 2, so I only come 2 days a week for one of those 3 in a day. And the biggest summary of that was that they push more. They push things more, which is fun for enrichment and bad potentially for some vet. Not bad, different. It's enrichment for the keepers as well. Any other additional keeper comment or question from Nate?
Yeah, is the data showing any difference between the fur seals and the seals in like their performance? Like, is one species like doing it better or worse than the other?
Yeah, so right now the question was about the difference in species. So the northern fur seals, Isadora is our rock star. Sophia's ready to move up. This is no surprise, especially about Isadora, to anybody who works with these seals. So they're doing really well. Misha's on like the touch white stage. Nika, we're coming back to. And then the harbor seals, Hula is more the rock star. She's still on touch white though. I think she'll move up now that her touches look really good. So they're all at different stages. From that, I feel like the fur seals have been easy to work with. But it's also, there's a lot of personality involved in this. I mean, even working with chickadees, there was more personality involved than you would expect. There's a lot going on with them. Seals, it's even larger, the personality differences and the progress through. So we're doing it on an individual basis. The furs are a little bit faster.
So the differences between like individuals are almost as significant as the differences between species.
It sure feels it some days, yep.
Yeah, when you say like faster or slower, like
Yeah.
what does that timeline look like?
What does that timeline look like? I wish I could give you a very simple answer. There are so many components with our scheduling for the most part. When we decided to move back from just everybody working with any individual, they specifically assigned seals to specific trainers. So at that time, Heather had a few individuals, Karen had a few individuals, and Talia had a few individuals. So if I'm only coming in on Tuesdays when I'm teaching Monday, Wednesday, Friday, it might only line up with a particular keeper. So I can't say it's necessarily the individual. It was more our scheduling opportunities. And then again, how that works out with their own schedule as a seal, as an individual. Yeah, Shannon.
I was just curious, with your wallabies, when you were doing the cooperative task, did you find that there was one of the two that tended to initiate that cooperative task more?
So I'd immediately answer with Grace and Polly. So Grace and Polly are mother-daughter, and when Grace is around, Polly does nothing. She just wants mom to do it. So we haven't had a successful pairing of pulling with those two because Grace pulls and Polly stands there. So that one's not going super well. And then Polly and Arvo. It was Polly and Arvo. No, bad combo. Toki. Toki and Polly were a little bit aggressive. So it's not cooperative. It's a little more combative. But we're seeing cooperation with 4 of the 6 pairings. And that's running 1 session with each of those, so 10 trials. And we're already seeing a lot of success. So we're pretty thrilled for what the future looks like. Also, the immediate question that comes up about social cooperation is how do you know that they're actually cooperating? What if they just conveniently are pulling at the same time? Yes, I hear you. So what this is what's called essentially a no delay testing. And the idea is once they're both within the vicinity, the ropes are released, they both have a chance. It's been working out well. But to be even more convincing in terms of experimental design is what's called delay testing. So what you do is you have one wallaby out, the second is withheld, maybe 30 seconds, for example. We haven't designed our methodology yet. We're not quite there. But you would have the one released, then you would release the second. And so if the first one is capable of withholding pulling until the second comes, it means they understand the apparatus. They know how to be cooperative. And if you if you YouTube wolf rope pulling social cooperation, you can see this. It's really cool. So the wolves will go up, stand there, wait until the second one comes. And it's extremely convincing evidence of this social cooperation. So we hope to do that as we move into the fall. Any other questions? Stephen, there's someone behind you first. Yep.
Sure. With the like global versus local, can you
Yeah.
hear me okay?
Sorry? Yeah, I can hear you.
With the like global versus local thinking, like I know you mentioned a lot of birds and mammals and the bees, like what other cool like facts has this like research been done on, or is it mostly like birds and mammals, or?
Honestly, yeah. So it was mostly, global local has been mostly studied in primates. So it started with lots of human experiments across the board. Every way you design these experiments were global. And then it extended into primates, and that's when things got weird. And then it's some odd species, like I mentioned, but the methodology hasn't been particularly consistent. So I don't have any other like super fun, crazy species to mention. We're working away on the bird front with Dr. Suzanne Gray, and then I'm starting to extend elsewhere, obviously, with these 2 species, the harbor seals and the northern fur seals, and then we're hoping to move into otters. There's conversations about that we still need to have. So hopefully I can show you otter stuff someday in the future. Stephen, do you still have a question?
Yeah, sure. Thanks for your talk, Jenna.
Okay, thanks.
On the global versus local testing,
Yeah.
do people ever look at things like the time taken to answer a question?
Yeah, so right now the way the accuracy is being produced is literally the first decision. And we're doing blocks of 8 trials, often 16 if we can fit it in. The actual time it takes to respond is something you can enter into the program as well. We're not currently doing that, but you can kind of look back at the videos if that's something that we wanted to take a look at. But right now, the accuracy is the most consistent with the birds. Anything else? Yes?
I have a question about wallabies. Do they exhibit cooperative social behavior in the wild?
Wallabies can be solitary or in these small social groups. Steph, do you have additional comments about wallaby wild cooperation?
I don't know much about like cooperative methods used in the wild, to be honest. I
Yeah.
don't know if there's a lot of research done on that for wild populations, but
I feel like watching them eat, I haven't seen a ton of cooperation. There's a lot of, can I have that? So yeah, I will look into more examples of that. I'll put more things on Taylor's to-do list. Yeah. Good? Okay, thank you so much, everyone. Oh, it's raining.
So, yes, thank you, Jenna, very much for sharing all of your awesome research with us. Now, the night is not over for those who have time. However, Kayla and I need to talk about the rain.
The rain.
Whether or not
We can try.
Okay, we're gonna try. So, like Jenna mentioned, is you do have an opportunity to see one of the critters that she's been working on some enrichments for. So Cortez, one of our owls, and Michaela, one of our keepers with us for the last 8 years, and she's kind of working with the birds of prey. So for those who do not want the evening to end, we're all going to, and might not mind getting a little wet, we're all going to head up to the birds of prey where Michaela will show us a training session. You'll get to see the enrichment item that we're about to introduce to Cortez. And Jenna, you're still up for going?
Yeah, absolutely.
Jenna will be our